Hello everyone and welcome back to my channel Learn with Priya Singh. I hope you are doing all well and great. So it's been a while, but today I'm bringing you one of the most requested and anticipated videos on my channel, Normal Distribution in Statistics. So let's get started. Today we will be diving into normal distribution and understanding the concepts of normal distribution. But first, what is normal distribution? As you see on my screen, we have a bell-shaped curve. So that is another name for normal distribution. It is also called as bell curve. It is also called as Gaussian distribution because it was first studied and described by the mathematician Carl Friedrich Gauss. Okay, so normal distribution is a type of probability distribution that is symmetric around the mean. If this is the mean, it is symmetric around the mean. This is the mean. You see there is a symmetry here. There is a symmetry here. So most of the data points, they clutter around the mean. So you see more maximum values, they are cluttered around the mean. Okay, so when you look at the normal distribution curve, it starts at one point, which is called as the minimum and a maximum. So it starts with the minimum value and it goes up to the maximum value. Along this curve, you will encounter the minimum values, maximum values, and the average, which is the mean. So you can see the averages here. Okay. The curve or the bell curve should be clear to everyone now. Okay. Now let's understand what this curve tells us. What are the key parameters involved and how do we study this normal distribution curve? So before studying that, let's take a real world example of weight. Imagine you have measured the weight of 100 people. When you plot this data, you will notice that there are individuals with minimum weights and there are individuals with maximum weights as well. And then others who fall somewhere in between. For example, let's assume that the typical adult weight ranges between 70 to 80 kg. You will see that most of the data points or the samples will lie within this range. Maximum samples will lie within the 70 to 80 range. When you plot the frequency of these weights on the y-axis, you will notice that very few people, if you have the frequency on the y-axis, you'll notice that very few people, low frequency is for the people who have got minimum weight. Very few people, they have weights at the extremes, either the minimum or the maximum. So you see the frequency is very low for the min and the max, very low. While most of the people, they fall in the middle. Okay. So I hope you understand how you relate the bell curve to the real world example for weighing of adults. Now let's talk about the characteristics of the bell curve. So if you look at the center, so this is the center. So if you look at the center of the curve, you'll find the average point, which is also where the mean, median, mode are equal. This happens because most of the data points cluster near the center. The mean, median, mode coincide at the point. So most of the points are average weights. They are clustering around this point. If you see, most of the data points are here. Next characteristics is symmetry about the mean. When I say symmetry about the mean, the symmetry of the bell curve means that the values on the left-hand side, the values on the left-hand side and the values on the right-hand side, they mirror each other. The distribution is symmetric. Okay, I hope the slide is clear, makes sense to you all. Now let's move to the parameters. Let's discuss two key parameters that explains this curve, the mean and the standard deviation. The mean and the standard deviation. First of all, the mean is a location parameter. It tells us where the curve is centered. Okay. For instance, if the mean is at 50, the curve will look different than if the mean is at 30. So it tells the location of the curve, where the curve will go. Let me explain you more. So, for example, in this slide, so as I mentioned, mean is a location parameter. If the mean is centered at point number 1, the curve will look like this. Let's say if this is the mean, the curve will look like this. If the mean is moved to here, the curve will look like this. If the mean is moved to here, the curve will look like this. So it tells the location of the curve, where the curve is centered. Okay. The second parameter is the standard deviation parameter, which I told you it's a scale parameter. It tells how spread out the values are. A larger standard deviation means the data is more spread out, while a smaller deviation means the data is more centered around the mean. If you look at chart number 3, it has small widespread. That means data points are centered around the mean, whereas white curve, which is the curve number 1, if you see, it is ranging from here to here, whereas the second one is the narrow one as compared to the third one. Okay. So I hope everyone understood. If it's a smaller standard deviation, means the data is more centered around the mean. So if it is a smaller standard deviation, you'll have most of the points centered around the mean. Okay. Now let's visualize all of this with an example. So suppose we have values like 20, 10, 20, 30, 40, up to 70, with 40 being the mean. So this is 40, which is the mean. So if we plot these values on a normal distribution curve, the values will spread symmetrically around the mean. So if this is the mean, this is the normal distribution curve, you see the values are spread symmetrically. The values between 40 to 50, this to this will be one standard deviation away from the mean. From 40 to 60, it will be 2 standard deviations away from the mean, and from 40 to 70, it will be 3 standard deviations from the mean. Similarly, from 40 to 30 on the left-hand side, it will be -1. From 40 to -20, it will be -2. And then till here, it will be -3. Okay, so on the right-hand side, it will be 1, 2, 3 standard deviations from the mean within positive values. And on the left, it will be -1, -2, and -3 from the mean for the values on the left-hand side. Okay, so this is the way how we can read standard deviations. So the standard deviations helps us understand how spread out the data is. So wider, if a wider curve indicates a larger standard deviation. If the curve is very wide, it means you have the values spread widely across, and a narrower curve indicates a small standard deviation. Okay, I hope you've understood both of the parameters, the location and the scale parameter. Now let's quickly summarize what we studied in this video. So the mean represents the center of the curve. The standard deviation represents the spread or the variability of the data. Okay, so I hope this explanation of normal distribution was clear and helpful to you all. I see you next week with more exciting content. Thanks for watching, and don't forget to like, comment, and subscribe.